While it is theoretically possible to apply the quadratic formula or factoring to a problem of solving an equation in more than one variable for a letter, realistically we're going to see that the square root method tends to apply here. We're given an equation in x and y and asked to just solve it for y. The reason that we can see the square root method applies is because y appears only once in the equation. So when the variable appears only once, it generally makes sense to solve by moving things away from that variable. Those things that you're moving away are the things that are different in one kind of equation over another. So we're going to try that approach. In order to solve this using the square root property, we need to start by getting this squared expression alone on one side of the equation. So let's isolate this first. We're trying to get closer and closer to the y, just getting y all by itself. So first I'm going to isolate the whole squared expression that y is in by subtracting off my x squared from both sides. So that looks like y plus 1 squared equals 9 minus x squared. Now I'm going to apply the square root property, which says I can take the square root of both sides, but that I have to remember always to consider the positive and negative square root. I only have to put that on one side because it becomes redundant to put it on both sides. So on the left-hand side, I just have y plus 1. On the right-hand side, I have plus or minus the square root of 9 minus x squared. Even though both of these terms individually are perfect squares, the fact that I have two separate squared terms instead of one whole squared expression means that I can't just take the square roots of each of those terms individually. I have to leave it in this form, even though it looks like it can be simplified. The square root of 9 minus x squared can't be simplified. I have to leave it in that form. I'm going to continue to move things away from y. So this plus 1, I will get to the other side by subtracting, and that leaves me with y equals, I could go ahead and put the negative 1 first or last, it doesn't really matter, I'll put it last, plus or minus the square root of 9 minus x squared, and this minus 1 is not inside the square root, so it has to be clearly written outside of the square root. This is now solved for y. The next question I have, is this relation a function? This is where we want to remember the definition of a function. Remember, the definition of a function is that for each input we have exactly one output. In this case, the plus or minus symbol means that for any value of x that I choose, I'm going to evaluate this square root and then I'm going to turn it into two numbers, the positive and the negative version. So the plus or minus symbol generally results in an equation that violates the definition of a function. It creates two outputs. If we want to just see an example, I could say x equals 0 is a pretty simple one. If x equals 0, y is equal to the positive square root of 9, which is 3 minus 1. We get 2. And y is equal to the negative square root of 9, which is negative 3 minus 1, which is negative 4. So I can come up with an example of an input that has two outputs, and therefore this is not a function. Generally, if we have y squared or some squared expression including y in our original equation, we're going to have a result that's not a function because we introduced that plus or minus square root in the process of solving for y.